Hello and welcome to the Rubber Duck Dev Show. I'm Chris.
I'm Cruston.
And tonight we're going to talk about the top 5, according to OWASP, security vulnerabilities in your web app. Yes, your web app. It's all vulnerable. Before we get into that, though, week in review. How was your week?
Okay. Did a little bit of Postgres consulting, a little bit of Rails consulting, but I spent a lot of time doing performance because, like I mentioned, I think it was last week where I implemented Skylight, APM, application performance manager for my application. I just started going through the process of whack-a-mole and looking at, okay, what are they have a agony score, like how slow something is. So I was just saying, all right, let me look at this one. Okay, what can I do to, improve that? Okay, go to the next one. And then of course you make all those changes and now you got a new set of endpoints that have certain agony scores. Like, okay, let me look through these. So I spent way too much time doing that. It was for the better in that, okay, now everything's even more performant, but it's like, okay, I got to get back to my feature development I'm supposed to be doing or whatever else. So it's like I could continue doing this for a month. And it's not just that it's poor performing, but if I wanted to get down to, not sub millisecond, but very small response times, I could keep doing it. But it's kind of like,
hooray for rabbit holes.
At what point is the amount of time invested worth, the gain reflective of the amount of time invested?
Yeah.
So I'm kind of like pulling myself away from it, like, all right, got to focus on other stuff. And other than that, the only other thing I was working on was a website redo. So I'm in the process of making changes for my website for my application too. So a little bit of marketing following on from the marketing training I had a week or two ago. So what about you?
Well, so our big client had a production release last week, so most of the week has been spent, just doing shaking out the rough edges and doing the bug stomping and all those fun things that go with big releases. So it's been a lot of little code tweaky things, kind of a death by 1,000 paper cuts kind of week. So no big projects, but lots of little admin things, and one of these days I'll get to code.
Well, did some of these involve little bug fixes in coding or?
Yeah, there were little bug fixes in coding. We have run into a weird issue with my all-time favorite thing, time zones, that we're trying to figure out. We still haven't figured out why it was an issue. And of course, it happened in this one environment. We can't recreate it in any test environments. It's one of those things where, like sunspots had to be in the right formation for it to happen or something. It just is, it's weird. So yeah, gotta love those. So I
sorry, go ahead.
I spent a good bit of time just trying to recreate a particular problem this week because we just haven't been able to. In fact, I had a whole team of people trying to recreate this one bloody problem because nobody can figure it out.
Oh, good Lord.
Yeah.
I had a very interesting support call today where someone called in and said, essentially the complete or submit button to submit a form was like gone. It just wasn't there. I'm like, well, that's the point of it. It needs to have that button.
That's the one thing that can't be missing.
Exactly. And so my application has a way to style the page by having a GUI that you could say, all right, I want the primary color to be this, the secondary color to be this, the accent color to be this, and all sorts of different things. And what they had done is set everything to white.
Oh no.
And put an image on their form. So that was the only color or whatever. So basically the button was there, but it was white.
God, I hate those kind of problems.
Well, it was quite easy because I mean, it was a super fast fix because I said, well, what's the form that has a problem? Okay, this form. So I put my mouse where the thing was, and it made the animation, the hover animation. So I'm like, okay, it's there. And then I said, it's got to be styling. So I looked at it, I right clicked it, and I turned the styling off or whatever was set to it, and poof, there's the button. So I'm like, okay, so where are they? You know, when I went to the page, call it a page style feature that allows you to change all the different colors and certain features of it. And I was they had set everything to white because they just wanted to have just their image in the form and nothing else.
So you had to call the client and say, "Hey, Tweedledee the Wonder Dummy has been in your settings here." And
no. It's just like, okay, well, that's one way to do it.
it's a
But
thing.
we have the ability to actually custom style the buttons too. So made the ability to change it to what they wanted. So anyway, but that was an interesting discovery.
Oh boy. Oh, the things you run into.
Or they're the things you don't expect. Like,
Right.
no one would do this. Yep, they will.
I don't need a test for this. Nobody's that stupid. First person that gets it.
No.
Oh man.
No, I mean, because yeah, there's certain reasons why. Yeah, it wasn't obvious when they were changing it that it would have this effect because it was actually on a secondary page that this particular button was missing. But,
well, and that's one of the issues with having very flexible stuff. It's great that it's flexible, but then there's also complexity that goes with it, and a lot of you can easily have unintended consequences with things like that. All right, so fun week, but let's get into why we're here. We're going to go through the first 5 of the OWASP Top 10 Web Application Security Risks. This is the 2021 edition. So this was the biggest things from 2021 that came out. So this is as current as it gets from a statistical standpoint. We don't have time to do all 10, and quite honestly, 6 through 10 don't terribly interest me. So yeah, I just didn't want to. Anyway,
even the fact, well, we had discussed security issues in the previous episode, so I was surprised that things moved around as much as they did. Like, for example, the number 2 slot went all the way down to, I think, number 7. And the one that's been in the top slot forever, it seems to be injection, went down to the 3rd spot, you know. So I was interested in seeing all the different changes that have been made.
Yeah, and
with this new release.
Personally, I was very surprised that injection went down because SQL injection is like one of the biggest things I run into in the wild. It's like I run into that all the time.
Well, apparently the new number 1 is taken over. I mean, because they've been harping on it so much, maybe it's finally started to sink in.
I hope so. And these are all important things. Now, out of the first 5, some of them are going to actually be code issues, things you need to be careful of in code, and some of them are infra issues. So if you're on the coding team and you've got an infra team, you won't have to worry about half of these. So, but if you're small shop, you got to think of them all. So we're going to talk about it. Try to talk about it in some plain English and not get too overly technical here so that we can all understand what we're talking about, because I'm a dummy and I need simple language. So, number 1, broken access control. What does that mean? It means you didn't program your stuff right, is basically what it means. So essentially what this is your authentication and or access systems are not working properly. So you don't have the principle of least privilege employed, where people are granted rights instead of rights are taken away from people. So by default, you don't give people access to anything until you specifically say, hey, you can have access to this.
And this could also be as simple as you're supposed to be, a particular endpoint supposed to be behind a login, but it's not.
Right. So yeah, it's not just for front end stuff. This has impacts APIs and things like that.
Well, I'm just saying you have a page that it's even a front end page, but it's supposed to be behind some sort of form of authentication, but it isn't.
Right.
And
So
people can visit it without having to authenticate.
right. So one of things, examples of this might be that you have a login system, but I can go to your website and I can put in a specific URL and get there even without logging in, even though I'm not supposed to, because that particular path isn't behind the firewall, as it were. So that's an example of this kind of stuff. But basically, it's allowing access or having holes where people can get access to things they shouldn't have access to. Whether this is on the API end or on the front end. So they talk about ways to prevent it, like what we mentioned earlier, deny by default. So your assumption should always be you can't have access to this. And then I will grant you access when these conditions happen. Unless you're a very public thing, public resources is fine. You open those up, but even then, you want to start with them locked down and say, okay, this is something I want to make public on purpose.
And if you're using a good library or libraries for authentication and authorization, they should be handling it in this manner.
Right. Yes, they very much should be. If they're not,
get a new library.
Yeah, I really would get a new library, because this stuff is, OWASP isn't messing around. If it's number one on their list, there's a reason for that. It's a problem. So don't think that this isn't a big deal. Go get yourself a library that handles this stuff. This is also, I think, becoming more prevalent because 10 years ago, web apps were kind of one server things. But now we've got this distributed architecture stuff and microservices and, the database over here and the one service over here and talks to this service over there, and, 850 different AWS pods running. And there's things that people are getting access to things that they shouldn't in there. Like one of the things they talk about in here is CORS, which is the cross origin resource sharing. I could not think of the word. Object was where my head wanted to go. That ain't it. But basically, saying, hey, this website can get and receive objects from this other location, and it's okay. But if that's not properly configured, then people can go tunnel through that if you don't have it walled off properly, and if you don't have the back end set up with proper stuff. So you got to be careful about your access control, because that's going to be the first point of attack on your app. People are going to want to try to figure out a way to crack into your access and get to places that they shouldn't be.
And the one thing that it also mentions here is that from the infrastructure side is disabling web server directory listings. So if you have misconfigured your web server and someone can just get a directory listing, that could potentially get access to files they're not supposed to, like your whole Git repository or whatever.
That could kind of put you out of business a little bit.
Just a little bit.
All right, so Number 1, broken access control. Lots of fun. Number 2, cryptographic failures. So this has more to do with how you're storing data, and how you're transmitting data. So, like, you have to be careful you don't send passwords in clear text through your system, because people can snoop on that and start popping passwords out. That's not something I've really seen very much in real circumstances. Not for a very, very long time. People have kind of wised up to that. But there still are things where you can find stuff in log entries that shouldn't be there. Sensitive information that should either be eliminated or encrypted if it's going to be there. If you're using old crypto algorithms like SHA-1 or some other old outdated ones,
MD5.
MD5, yeah, you shouldn't be using those anymore for your crypto, because they are essentially cracked and useless at this point. Doing things like making sure you're using TLS, the latest TLS, making sure that your certs are all validated properly and they're in the proper trust chains, and that you don't have, you're not storing passwords that aren't properly salted and encrypted, that they are essentially uncrackable. And not only passwords, but any other sensitive information, especially sensitive information about your customers. So you just want to be careful with that. But this all has to do with how you're storing and transmitting data, so that you don't expose things that shouldn't be exposed. So this is kind of half in the programming area and half in the infrastructure area, because some of it has to do with transmission and SSL and TLS and certificates and that kind of stuff. And some of it has to do with what am I logging, how am I sending things, how am I storing data. So this is one that everybody will need to kind of pay attention to.
So I was just kind of thinking, maybe for each one of these, we should also think about what are some mitigation methods. So I know there's all the prevention methods, but what are some easy ways to do it? Now, thinking back to the first one that deals with broken authentication, I think testing can go along towards helping you prevent that. So if you have
For sure.
developed tests to know, okay, these pages should be behind an authentication link, and I can validate that you need these particular rights to view this particular page. I think you could write tests to handle some of that, as well as knowing
absolutely.
your authorization and authentication libraries. Now, in terms of this one, I have a hard time thinking of some ways to mitigate some of this. I mean, because it's really, you need to go through and track the data that you're tracking that is sensitive, and determining, do we need to store it? If we do store it, do we need to encrypt it or not?
Right.
So I think this will be a lot harder to do.
This is one of the ones where you need to go through and understand the things to look for and to be aware of, and you kind of need to do audits on a regular basis for this kind of stuff, because there aren't really a lot of automated tests you can do in this area. Like the other area,
and I don't think I'm not familiar with services that would help you. Like, there are services that can hit your application looking for vulnerabilities, but I don't see them being able to discern some of these.
Yeah.
Although it will capture using outdated cryptographic methods.
Right. And you can do things like, making sure that you can get your trust chain checked and make sure that your certs are all right, and So some of this can be tested, but a lot of it is just you have to pay attention. You need to catch if you're looking in logs and you say, oh God, there's passwords in here, raise the red flag. Let's fix this. That's a problem. But this one takes a lot of just paying attention, doing audits, and being just familiar with the things that you need to look out for. That's why it's important to talk about, learn, and understand these things, because some of it is just you need to look out for it.
And a lot of frameworks have the ability to handle some of the, like at least the filtering, like filtering from logs. You know, you can give them particular keys or something to look for and not included in the log.
Right. Yeah. And like you said, on the first one, the access control, that should absolutely be tested. I test, and it seems a bit pedantic sometimes to write tests to say, hey, this person should have access to this page and shouldn't have access to this page. You've got a lot of tests going back and forth. But I'm telling you, if you don't have those tests, you have no idea how secure your access control is. Those are
you
usually
don't know when you make a change and you flub something up.
Right. Those are usually the first tests I'll write, and I write those for every page for every user type. And yeah, it's a lot, but holy crap, is it nice to have it when something goes bad, because you can catch it before your customers do and you get sued. That's never good. All right, so number 3, injection. This is actually the one I'm most familiar with, because this is the one I've seen way more than any other security issue. The good news is, in most cases, this is, for most languages, this is actually automatically discoverable with static code analyzers like Brakeman. Brakeman will pick this stuff out and say, hey, you got some injection problems here.
And that's, for those who are wondering, that's the Ruby static analyzer.
Right. And other languages have those too. And they've done a lot to, and I think that's probably one of the reasons that this has kind of fallen out of the top spot, is because those static analyzers have done a lot of work towards surfacing these things before they get in the wild. And that's great. But if you're not familiar with injection, there used to be a separate thing called XSS, or cross-site scripting, and a separate one called SQL injection. Those have been kind of glommed into this and included in here. But essentially, this is bad actors injecting stuff into forms or URL parameters or other areas of your code or other areas of your app that take user input, and they can do things like put JavaScript snippets in there that'll run stuff when you take it into your server if you're not careful about what you're taking. So one of the common ways to do that was called SQL injection. So they've got some examples here, but basically you let somebody, let's say you've got a page with a lot of things of your customers and you have a filter, right? So a person can fill in like a partial email address and it'll filter that out, and that email address is passed in a parameter to run the filter. Well, if you don't properly protect that, what I can do is I can put JavaScript in there and wrap it in quotes, and then when you go to run that query, it'll execute the JavaScript and I can get access to your system.
Well, it's not actually, it's not even JavaScript. In other
Doesn't
words,
have to be.
Like, yeah, well, in this example here, it's they're just putting in a sequence that basically returns true. So give me all the records of something.
Right. So you have to be really careful about user input, and that's the injection. It has a lot to do with user input and protecting user input. In most cases, In fact, I would say in all cases, unless you have a really, really, really good reason, you don't want to ever take user input directly into something. You want to put it somewhere and then make sure that you're sanitizing it, and then you put it into whatever it is you're going to run with it. So that is one that before Brakeman was in those static analyzers were routinely adopted, I saw this a lot. I still see it quite a bit if people aren't using the static code analyzers, because and I don't see it when I run into people who are using them very much, because those static code analyzers pop these out real fast. And then the people they fix them and go on, and you don't have these problems. So that's the best mitigation, is run the static security code analyzers for this kind of stuff to make sure that they're not finding anything. Now, those aren't 100% accurate. What I have seen is that you'll get sometimes false positives where it'll say, hey, I think this is injection, but it's really not. But I'd rather have that than missing it.
Yeah.
Because I can make a decision about it. But this is almost purely on the programming side. So if you're on the programming team, you should know about this. Number 4, insecure design. That seems fairly broad. What? So let's see what they're talking about here. Insecure design is a broad category. Well, yep, it sure is. What I get from reading this and researching this is that what they're talking about here is design problems that it's not bad coding. It's that you have designed something that exposes an attack vector.
Bad choices.
Yeah. You've designed something in such a way that it exposes attack vectors that you hadn't anticipated, but it's not because somebody left something open in the code. It's because you left something open in the design. I know that's...
And what's helpful is the example, like text scenarios, if you scroll down a little bit.
Yeah.
Like that first one is basically if you're using a question and answers method to reset a password, for example.
Right, which I hate.
They're
those
saying
things.
that's, yeah, which is, so they're basically saying the, what is it? The application security verification standard and whatever that other acronym is, there's all these standards that say you should not use this. And of course, I'm looking at this and I'm thinking, well, then why are my banks still doing this?
Right? That gives you warm and fuzzies, doesn't it? Another example would be like using, hey, let's use the old CAPTCHA system because it was nice and easy. Yeah, it's not terribly secure. So
yeah,
that's a bad design decision.
Or maybe it once wasn't okay, but now not. Now they all want to go to multi-factor authentication and whatnot.
Right. So. But yeah, and at this point, because it's been cracked, it's as useful as MD5 is for cryptography. So.
And then the second scenario was interesting too, is where you basically, they're giving discounts, but if someone hits it simultaneously to grab more discounts than they should, it results in a loss in income. So that's a poor design that you haven't, I guess for like a better term, serialized the processing of transactions coming through. And even the last one's talking about a lot of bot protection. So if someone's trying to spam with bots, again, going back to the serialization, not being able to.
Those are your favorite people.
Oh, yes.
So, yeah, this one's kind of hard to define. It's really really broad, and it's kind of hard to point to specific examples of this because design is so amorphous. Every app has a different design, and makes different design decisions, and there are thousands of design decisions even in a small app. So it's kind of hard to pin this down, but you do want to make sure that you're thinking through these things as you go into design phases for areas of your product. Make security something that you talk about during the design phase. It should be
Yeah, and all the prevention up there, there's a lot of consultation or consultative discussions about how to design the system
right.
securely.
And honestly, if you're getting into systems that are prone to security issues, like you're going to take credit cards, or you're doing something with people's money or something like that, it may be a good idea to get a consultant to talk to you about design who specializes in that kind of stuff, because that stuff is complicated. There are laws around it. There are lots of different laws depending on where your app is accessible from, and you're not going to know all of them unless you're the guy that specializes in that. So you kind of have to assess how risky your app is and how much you need to pay attention to security during your design process. But you have to pay attention to security at least some. It's something you really want to think about, because as more and more laws go into protecting consumers, there's a lot of laws that have gone in the EU that one of the reasons that you started seeing all these hey, we use cookies notifications on every website is because the EU passed a law that said you have to do that.
GDPR.
Yeah. So it's the protections for consumers and end users are getting ramped up, and so there's more and more laws that you have to be careful of. So security is something you want to put front and center in your design process. All right, and the last one we're going to talk about tonight is security misconfiguration. This one is almost purely an infra problem. So if you're a programmer and you don't work with infra, skip out on this one. If you're an infra person, I'm sorry, but this is all you. So basically, this is you haven't set up the backend security configurations. Probably you haven't set up users properly. You haven't set up your database walling properly. You don't have security settings right on app servers. Nginx is too open. There's just, it's all the back end security stuff for your servers and your infrastructure that's being talked about here. Again, this didn't used to be as high, but I think that has a lot to do with the fact that it didn't used to be as complicated, because most web apps were just, here's a server, it runs my app, it has all my stuff. I lock it off, and away we go. But now we've got these distributed servers and AWS instances and Docker pods and all kinds of stuff going on. And the security configuration has gotten significantly more complex, with cores and the talking between database pods and pods for this service and pods for that service. So they have to be able to talk to each other, but they have to lock off things that shouldn't be there. So it gets complicated, but that's all the back end things. So how do you deal with that stuff? Well, one thing is you really got to have kind of checklists for thinking about all the little security things. If I'm setting up a new server or I'm spinning up a new pod, I better check these things to make sure I've set them properly.
And there are some automated tools that can confirm, okay, is directory listings enabled on your web server?
Right.
Do you have certain default accounts reset or disabled? So there are some cloud vendors that provide tools to capture some of this.
Right. And another big thing to mitigate this is make sure you don't have any services or programs or apps running on your server that you don't need. If it's just some pre-installed background piece of crap that you don't need to use, get rid of it. Unless it's necessary for the OS, you don't want it running because that's just another attack vector for bad actors. So simplify your system as much as you can. And then this is another place where you can't automate a lot of this. You can automate some of it, but a lot of it is being aware, doing regular audits, and making sure you have lists of things to look at and pay attention.
Or take your list of things and you use Ansible, Terraform, whatever to configure your systems, so that we have your list become documented ways of building your infrastructure in a secure manner.
Right, and they should. But even then, you still you want to audit those things every once in a while too, because you know, like Linux gets an update. Well, okay, that may have changed something, and now I've got a hole here. That doesn't happen often with Linux, thank God, but it can happen. So these are tough things, but security is becoming more and more important. And there are more and more laws popping up that will just, if you're not careful with this stuff, it can completely destroy your company. You know, all it takes is one massive lawsuit because you lost somebody's credit card number, you know, and that's bad news. It's just not a fight you want to fight. So be in front of this stuff. And security should be a first-class citizen at every stage of your discussion of your app. Through the planning, through the coding, through the infra setup, in your testing cycle, your QA, and even while it's in production, you should be monitoring your production for any signs of security holes. And there are certain things, like if you're storing credit card data, by law, you have to have certain testing done, like pen testing and certain other things to make sure that you're in compliance with the laws. Even if you're not required by law, if you've got a lot of personal information from customers, you may want to get some pen testing anyway, independent pen testing. Because if something happens, you can say, hey, look, we got tested, you know, we were proven secure. We did our due diligence. But this isn't the most fun topic for a lot of people. There are some people that love this stuff. They make their living off of security things and they love it. For most programmers, it's not something we really like to think about, but we just gotta make everybody safer and pay attention to this stuff. Okay, boys and girls, I think that's it for tonight. You got anything else on this topic? Nope. All right, if you enjoyed that, please like and subscribe and follow if you're seeing us on Twitch. Mash all the buttons and ding all the bells. Join us every Wednesday night, 8 p.m. Eastern, for more Dev Talk. If you have friends, which we know you do, bring them too. Next week, what are we talking about next week?
The other 5?
Next week, more security talk. Whoopee! If you have a talk with
And maybe we'll throw a little something else in there too.
Yeah. Because 6 through 10 were a little less saucy. But if you have a topic that you would like to see us cover on the show, please leave it in the comments below. We do read all of those. Our podcast is available in all the places that podcasts live. Visit our site at rubberduckdevshow.com. You can sign up for our newsletter and find all our videos and podcasts there. You can also follow us on Twitter at DuckyDevShow. Till next week, happy programming.
Happy programming.